Hi, this video is about color and how we perceive color. So in class I went through this, but I did want to give an opportunity to anybody who needs to review it or simply wasn't there to be able to see what we went through. So I'm going to this is what we call a psych sim. It is supposed to be intended where students go through it individually. However, the problem is that I can't have you go through it individually because it uses Flash Player. So I will sometimes bring these up in class and I'll just kind of run through a few things with them. So if I go and flip through a screen real fast, yeah, don't worry about it. And I'll kind of stop and summarize the ones that are important. So this is, like I said, looking at color specifically. So there's a couple of reasons why I'm showing you this. So this is this idea that how we can interpret color. So basically we have our sensation that we pick up a light that's coming from a particular object that goes into our eye and goes to the back of our brain. So going through our eye will come through the pupil, through the lens to the retina, and our fovea is going to be where the focal point, where obviously the flower is upside down, but the information gets passed through the optic nerve to our brain. And so our brain will then look at it and say, hey, you know what, this is a yellow flower. So this is just kind of looking at the difference as far as what parts of the light is going to actually tell us that it's yellow, what parts of the light actually tell us, like, if it's a bright light versus a very dull light. So this one is obviously talking about how the colors, depending upon the wavelength of the light, and this is obviously the color spectrum. And then this one is looking at the brightness or the intensity of the light is going to be more a result of the amplitude or how high the wavelengths are. I'm kind of skipping through those. We don't care about saturation. Okay, so the trichromatic color theory is one of the ones that I wanted to talk about. So this is the idea that, remember, in our retina we have rods and cones, and so the cones are the ones that are responsible for color. So according to the trichromatic color theory, we have three types of cones: blue, green, and red. And whenever we see color, okay, we are activating different cones. And so there is going to be some sort of combination between the two or three of them. So this is just showing you kind of wavelength-wise what color you would actually see. I can't remember where I was at. Oh, this one. This is kind of an interesting thing. You can actually move the slider back and forth. And so, like, for example, when we see, it says experienced hue is basically an orange, we're basically activating a lot of red cones and then some of the green cones. Whereas if we're, for example, seeing like let's see if I can get a yellow in here. These are more green than anything. What about more like a purple? Obviously we would have more blue than red, but it gives you an idea of how many cones are actually responding. So that's the trichromatic color theory, and then there's a lot of stuff in here about mixing colors, blah blah blah, to be able to make different colors, mixing cones to get different colors. So what explains color blindness? Well, color blindness is basically saying that one or two of your color cones are basically not working. So most common is red-green colorblind, meaning that you only have what we call a dichromatic color, so you can only see you only have two active cones, or you could have a monochromatic color, so you actually have only one active cone. So if you are, for example, colorblind, this would be a test for a colorblind person and they would see absolutely nothing. But if you are not colorblind, then you would see that there is a 74 in here. So see the 7 in the green, and there's a 4 over here in green as well. But if you're colorblind, you wouldn't be able to pick that up because it would all pretty much look the same. So they can't tell the difference. Generally speaking, colorblind is going to be linked to, it's a genetic trait. Generally it's usually in males, but it can happen in females. So that is generally what happens. Okay, so that's one explanation of color. Another explanation of color is this idea of opponent processing. Okay, so the opponent processing theory basically says that we are going to have kind of like there's three, it says 3 opponent processing channels for our cones. And so we have 2 kind of channels. We have channels for 3 different areas, right? So it's either red or green, blue or yellow, white or black, okay? And so what happens is that we are kind of turning different channels on and off. But when we stare at a particular color for too long, we wear out that channel, and so that it basically flips to the opposite channel. So I'll show you what I mean, and this is part of the reason why I really wanted to show you this particular one. So here's what you have to do. So to demonstrate opponent processing, what I'm going to do is I'm going to press the start button, and I want you to stare at this X right here in the middle. So stare at the X in the middle, and after about 20 seconds, the colored circles are going to disappear, and you're going to see these after images, okay? And if you blink your eyes a couple times, it says that it intensifies the images. But it gives you an idea of what I'm talking about with this opponent processing theory. So here we go. All right, did you see it? So you should see some sort of blue and kind of a pink and yellow, and you're going to see all these different after images, right? So again, basically what you're doing is that by staring at the X, it's kind of in your peripheral vision that you are basically having, you're wearing out your color receptors in those particular areas, and so then you're seeing the opposing color. So another example of this is this ultra color sensation, and this is kind of an interesting one as well. You are going to stare at the picture, right? Okay. Obviously, they look very different. Okay. What I'm going to do is I'm going to click on the photo, and what's going to happen is that it'll start a 20-second timer, and it's going to have this X in the middle. Okay. You're going to stare at that. Try not to move your eyes at all, and then after the 20 seconds, the photo will appear, and it'll actually look completely different. So let's try it. So stare at the X. Try not to move your eyes. All right, so how did it look? Did it look any different? So it probably, for a little bit, is going to be very similar, okay? It's going to be kind of flipped because you're basically wearing out your color receptor. So again, that's the opponent processing theory. It's kind of cool. All right, so that's this idea. So it says that the 2 halves of the photo should look much more similar for a moment or two after viewing the color patches, because each patch is fatigued a portion of the yellow or blue channel. So of course, after a few seconds, it wears off, and our color sensation is the same. So that's pretty much all I wanted to talk about. Let me know if you have any questions.